This is IBM PC 5150, arguably the first computer ever made, and this computer is much more complicated than any computer that you could create on your own in your garage or on a software. In fact, that's the complication. These complications are the reasons that you have never seen a book or any video course or any course that has explained how to recreate this IBM PC or how to even analyze it down to the wires and zeros. When I say down to the wires and zeros, I mean this thing, that you just follow along every wire, understand exactly how everything works. But I want to explain you first what this computer is made up of on a high level. This is the case of this computer. And if we open this, we see three main boards. One of them is this one, which is called the motherboard or the system board or the main board. And as the name suggests, it's the main board of the computer. Inside this board, we see the brain of the computer, which is called the processor or the CPU. This is the 8088 microprocessor, which is almost the same thing with 8086. The differences would be explained later on. And if you go to the control panel or the settings of the computer that you are using to watch this lecture or that I'm using to record this lecture, you would see that it said it is a x86. It means that the processor that these computers are using are actually the descendants of the 8086, meaning in a way this computer is the ancestor of all the computers that you are seeing nowadays. So the behavior of all the computers that we see are in a way the improved versions of the computer that you see here. Other than the CPU, the brain of the computer, we see 64 chips here, or 32 chips actually, which each one of these chips is able to save 2 kilobytes of memory, or in a better way, 16 kilobits of memory. The differences would be explained later why we talk in this manner. So we have 64 kilobytes of memory on this board. We have also another 8 kilobytes of memory, which is used for the parity check, and parity will be explained later. We could also have 48 kilobytes of RAM or read-only memory here. Right now we have only 40 kilobytes. Now, one of them, this one is actually the BIOS, which is a small operating system inside this board. BIOS is just a form of an operating system. It does both the testing and also gives you some functionalities, gives the user some functionalities in the form of interrupts that, as I said, everything would be explained later. Other than that, we have 5 I/O slots here. These I/O slots are for a lot of times when we say computer, we are actually referring to this board. So these I/O slots is that we connect other boards to our computer. Now, why do we need other boards? Because imagine that the user wants to show something on the monitor, write a program that would show some images on the monitor. Now, what in general, what this user should do, or what the computer gives you, is that when you look at the manual of this 8088 microprocessor, you see that the CPU understands a set of instructions that we call the ISR of that microprocessor. The user would write a program based or using those instructions and put them inside this memory. The CPU would give the address of the memory cells, because we give the first address, the first memory cell that we have written or instructions in. The CPU would put the address of those memory cells. The memory would give the data or the instructions written on those memory cells. The CPU would read them, decode them, and execute them. But the thing is that interacting with the monitor is a bit hard. So the creators of this computer created another board and call it the graphic card. The graphic card acts as an interface between the CPU or between the motherboard or between our computer. We could even refer to that, and the monitor, because as I said, there are a lot of, it would be so hard if we didn't have this graphic card that the user had to take care of every little things, every little details and complications by themselves. So this graphic card has a set of instructions that it understands. So it tells the CPU that the user could just work with those instructions. The CPU would give them to this graphic card. The graphic card would translate them to a way that the monitor understands, and we see the results on the monitor. The main chip on this board is this one, which is called 6845. Also, if we look at our computer, we see these floppy drives, which you could put the floppy and would work at the permanent storage, meaning when we turn off the computer, the data on that floppy wouldn't be wiped out. Again, if we wanted to directly interact with the floppy disk drives is what we put the floppy inside. And floppy is just like the CDs that you see. So it would be really hard to work with the floppy to tell the floppy disk drive how to save the data or on which position. So we created another board and call it the floppy disk controller. Just like the graphic card, which acts as an interface between the CPU and the monitor, the floppy disk controller acts as an interface between the CPU and the floppy disk drive. So the user would write their programs in a way that the floppy disk controller would understand, a set of instructions that we will explain later that this controller would understand. And this is its main chip. Then the CPU would give them to this floppy disk controller, or FDC for short. The FDC would give them to the FDD, or floppy disk drive, and the floppy disk drive would write them on this floppy. So as I said, this is just a high-level view. What I mean by low-level is that we need to exactly follow every wire here. I was able to, in a way, well, you could say, reverse engineer it, even though it has actually a great manual. But I looked at everything and draw all the system board on my tablet here to follow along all the wire. As an example, when I tell you that you write your programs in the memory, it means that the user would write their programs and put them inside these memories or RAM. Then what the CPU would do is that you give the address of the first instruction of your program to the CPU. The CPU, here is actually our CPU, would put the address on these pins. It has about 20 pins, actually exactly 20 pins used for addressing, even though actually you could say more or less, and this would be explained also later, but the address of that memory cell would be put on these wires. It would go around a couple of latches, and if you follow along the wires, those wires would go through a couple of multiplexers. The memory, a specific memory would be selected. Those memories would put the data in the selected memory cell on this data bus and would travel back. The 8288 actually is another chip, the bus controller, that the CPU, in conjunction with the CPU, would create some control signals, would issue some control signals. The data in almost the same path would be read by the CPU, and inside CPU we have a control unit. Those data would be analyzed, and the CPU would understand what to do and how to execute that instruction using its control unit. So this was an overview on what you will be learning in this course. But as I said, it is really much more complicated than you think. In fact, there are a lot of requirements. As an example, when I say concept like registers, RAM, ROM, or this kind of thing, you should already be familiar with them. I actually created another course called creating a computer or a CPU using transistors and logic gates, which explain how you could create a computer of your own, which is almost the contents covered. There is a requirement, almost a requirement for this course. There are also other courses like the Ben Eater course, which explain about how to create a computer. It's better that you already know how to create a computer of your own, or at least be familiar with those concepts, with the concepts covered there, because otherwise this would get really hard for you. So this is an advanced course, especially when we get to the BIOS and analyze those things. We wouldn't go into a lot of things which are more like the introduction. So I hope you would like this course.